Hey, hello guys, this is Shubhobroto and welcome back to my channel circuiTician. Today in this video, we are going to design a buck converter circuit from schematic to PCB. Many of you know that what is buck converter, but who those don't know, buck converter is a type of circuit which step down the DC voltage. Like if you have 12 or 24 volt DC in input, but you also have a microcontroller circuit which needs 5 volt or 3.3 volt. So the buck converter will do that for you. And the buck converter circuits are very efficient than the linear voltage regulator. So today we are designing this circuit and the PCB in the EasyEDA software. So don't skip the video, watch till the end. Let's get started. So today we will design a PCB. Before that, we will draw the schematic. So first we need to know that what we are going to build. Today we will build a buck converter circuit using MC34063 IC. So we have to keep in mind that what component are available in the market. According to that, we have to design our PCB. So first we will choose the components from the library and then we will design the schematic first. So for that first I am showing you the circuit diagram. So here is the MC34063 IC. This is the internal diagram. And we also need some external component like this capacitor, resistor. Here we have a inductor, a diode, and more resistor and capacitors. Okay. So first I will take the MC34063 IC. For that I will go to the library and search for this MC34063. Okay. Then I have to choose the correct package because this IC is available PDIP and SOIC8 in both the packages. So as we want to make the circuit compact, so we will choose the SOIC8 package. So this is the SOIC8 package. So place this. Okay. Now we will need a capacitor. The value is 100 microfarad and 25 volt. So we will also search for that. So here is the through-hole capacitor. We have to take electrolytic capacitor because it will be connected in the input section. So there are various capacitors. This is the SMD electrolytic capacitor. For now, I am choosing this one. Okay. Next, we need a resistor. The value of the resistor is 0.33 ohm. As this is a current limiting resistor, so we have to take the wattage of the resistor, high watt resistor. And the size of the resistor will be 1206 as I have said before. So I'm not getting to search for that. So this is 3.9 ohm, not this. Or we can also search for 330 milli ohm. Sometimes I face difficulty to find the component in this section in the EasyEDA library section. So then I go to LCSC parts because finding the components here is more easy. So now in the product section, we will go to the passive components. Then we will go to resistors. Cheap resistor surface mount, as we are using SMD1206 resistors. So first we have to give the package size 1206. Then we have to give the value, that is 330 ohm. We have 330 milliohm and apply. You can also choose the other specs like tolerance, voltage rating. So we are taking this one. Okay, 1206, 330 milliohm. So what we have to do, we have to just copy this supplier part number, LCSC part number, copy this, and here paste in the library section. So you can see we can easily find the component. So this is how we will acquire all the components, and then I will show you how to draw the schematic. So I have acquired all the components we require for this PCB, and now we will start designing the schematic. I am giving a diode in the first section because we don't want that if we connect the polarity of the supply in wrong direction and the board will damage. So we are giving a diode, Schottky diode, that is 1N5819. So the voltage drop across the diode will be very less, like 0.2 volt. You can take the wire component from these wiring tools, or you can click the W on the keyboard, so it will activate the wire component. So this is how I have connected the diode. Then I will select these two components and slide it to the left. And now I will add the input capacitor, that is of 100 microfarad, and also connect this 100 NF ceramic capacitor for any type of noise removal. If the supply has any noise, so it will remove it, help to filter the input supply. Then again I will connect this. The pin number 6 is the input pin. I'll connect the positive input to the VCC. Now I have to show the circuit diagram. So we have to connect the pin number 7, 8 and 1 together, means short all these pins, and connect a resistor in between the V in pin or the 6 number pin and this 3 shorted pin. Okay, we have this resistor called as R0. You just click the space bar to rotate the component. First, I have to short these 3 pins, 7, 8 and 1, like this. Then put the resistor in between pin number 6 and 781, any other pin. Okay, now I have to see the circuit diagram again. Here we have a diode, Schottky diode, connected in between number 2, which is the output pin of this IC, and the ground. And we have a capacitor connected in between pin number 3 and ground. Basically, this capacitor is the timing capacitor which is responsible for the internal oscillation frequency. We are using a 470 picofarad capacitor, and a inductor of 220 microhenry is connected with the pin number 2. for filtering the output voltage. Let's go and connect these components. So first I will connect this capacitor in number 3. We will give the ground connection later on. Then the diode to the pin 2. When you have connected the wire and you want to drag the component, just right click and then you can drag the components. Then again press W to get the wire tool. So we have connected this inductor and now we have to connect the output capacitor, that is C4 470 microfarad. And we also have this ceramic capacitor for noise removal purpose, as we have also used this in the input section. We are also using this in the output section. Then here we can see there is a resistance divider network which is connected to the pin 5, which is basically the feedback pin of this IC. In this circuit, we are making a 5-volt buck converter. So the resistor we will be using, that is a fixed value. You can use a potentiometer to adjust the output voltage as well. Here in the data sheet, we can see two resistor. The value of the R2 is 3.6K and R1 is 1.2. But in my inventory, I only have the resistor value of 1.5K and 4.7K. So we are using those two resistor. It will create the output voltage of 5.16 volt. Okay, now I will connect this resistor. R2 will be 4.7K and R1 will be 1.5K. Done. Now I'm attaching a LED for indication purpose, and for limiting the current I will be using the 1.5K resistor. So while designing the PCB, you have to keep in mind if you can use the same value component, so you have to purchase that only. Okay, I can use here 1K or 2.2K, anything, but 1.5K will also work. That's why I have selected the 1.5K, as I'm also using this 1.5K here. So now I will connect the ground connections from here to here and here to this point. Input ground pad. Now we have to connect all the ground. While connecting in a wire in between anywhere, a dot will be created so you can understand the connection is successful. To also connect the pin 4 to the ground line. Now we have to connect this feedback point, resistor divider network point, to the pin 5. You can directly pass the wire, but I am creating a loop like structure so we can easily understand that we don't have to connect these wires. Okay, so for that reason I am making a loop like structure, because these two wires are not connected. Now I will connect the output pads. Done. So I have connected all the components successfully. Now we have to check if is there any error or not. Okay, for that reason we have to go to the design manager. After coming into the design manager, here you can see two things, that is nets and components. Suppose you have selected a component which don't have the PCB layout pins like the footprint only have the schematic. So you will see a error here in the component section. As we don't have such component, so we don't have any error in the component section. Then we have to check the nets. If there is any error in the nets, you will see error like if I disconnect this point and now the negative terminal of this capacitor is open, so it will show a error. Here you can see it will also directing to the point where the error is. Like if I in this position, if I am in this position and if I click it, it will go to that point to show the error. So just connect this. Okay, so I'm connecting this to the ground and rechecking for any error. In between doing the work, you should press the Ctrl S for saving the file. Okay. So we are done with the schematic. Now we will go for the PCB design. For that, you have to click in this icon. So here we have to give some inputs like the size, layer, and the units. I will keep it as as I am use unit only. And we are going to design two-layer PCB basic board outline rectangular. You can choose round, rectangular, circular, or any other custom, and give the start X as 0 and keep the board size as you want it to be. I'm keeping the width 20 mm, uh, 30 mm, let's say 30 mm, and the height 20 mm. Okay, you can adjust the board size later on also, and give the start y as the height of the PCB like 20. So it will put the board in the origin and the first quadrant. So for calculation of the components position, it will be easier because in the first quadrant X and Y both are positive. Now select this board outline and keep it locked so it won't move while you are dragging the components. First, you have to think where you want to put what component. Like you can't put the pads in the middle, so it will be uh, much hectic, or it will be more uncomfortable to solder the wet in the middle of the board. Okay, so you have to keep the pad in the side. So in the left side, I'm keeping the input terminals or input pads, that is V in and ground 1, and the V out and the ground 2 in the right side. Okay. Now for keeping a equilateral distance or equal distance, I say I will give the coordinate. X is 2.5 and Y 2. So I think it is looking nice in 2.5 comma 2 position. So this pad will be Y position will be 2 and the X position will be 27.5, as if we deduct 2.5 from 30, so it will become 27.5. So you have to calculate that way. And as the board height is 18 and we have a 2 mm difference in the y axis, though, so this y will be 18 and the x location will be 2.5. And this x will be 27.5 and y will be 18. Okay, equal distance. Now keep the legend inside the board, otherwise it won't be printed into your PCB. If you want, you can smaller the size of the legends. like 0.8 mm. Just adjust. Okay. Now in the circuit we have the diode first, right? The D1 diode. So here we can keep, because this pad of the diode is connected to the V in, so we will keep this pad in this direction. Then we have an input capacitor, right? The C1. So you can also look in the schematic while you are designing the PCB. So we have C1 and C2. Here we have the C1. Yeah, you can also press the space bar for rotating the component. Then you have to find the C5. If you are not able to find the components, because in some cases you have more than 50 to 60 components, just press Ctrl F and the designator of the component you want to find, then press enter. So here you can see it is finding the C5. Okay. Just drag it to the position you want. Oh no, it's not C5, it will be C2. Sorry. Okay, this is the C2. The connection goes to these pads, the anode of the diode. That's why I have rotated the diode in this direction. Now I am coming to the IC. As we can see here, the left right side, that is 5678 in the actual IC in the physical form. So you have to keep the right side of the IC in the side of input. That's why I am keeping this IC like this. Okay. We also have the R sense resistor, that is R0, this side. I will put this here. Now I will give the capacitor, the 470 picofarad capacitor here. This pin to this pin and this pin to this pin. You can see the red lines here, the thin blue lines. Okay, a bit like this. You can also place this here. While you will practice this PCB design, you will get the idea that what component you have to put where. I mean, which component you have to put where. Okay. For now, I am keeping the C3 here only. Then we have the diode. Okay, we'll do one thing. Put the capacitor first because it will take the space. Okay. You have to adjust the component to fit all the components inside the board. You can select these two components for aligning to the middle. I'm doing this. So we have arranged all the components according to our need, and now I will connect all the components. Okay. So to join all the components, we need a trace components. We can click here, and as well we can click on W to get the trace component or the wire component. I'm keeping the routing width 0.35 mm for our circuit. You can change this routing width according to your need, but as per calculation, if you need a 0.4 mm trace, you should take a much thicker like 0.45 mm trace for better connectivity, because sometimes the thickness of the copper may less while you are manufacturing the PCB. So if the calculation says you 0.4 mm track should be good, you should take 0.45 or at least 0.41 or 42 mm trace. I am here using 0.35 mm. Okay. I've connected the diode to the input, and now I'm connecting to the capacitor. First, I will starting with the top layer. When we will didn't get any space in the top layer, we will go to the bottom layer for routing the traces. I'm just connecting the pads. Here you can see like how you can understand which pad should be connected to another pad. For that, you can see here the net markings U1 underscore 6, and here also same. So you can connect it. Otherwise, you can see the net lines. Okay. Uh, by that, you can also find out like this pin should be connected to this capacitor. Okay. Or you can also connect here, but you also keep in mind, well, you also have to keep in mind that the line length should as small as possible. Okay. Now done. The pin number 7, 8, and 1 are shorted. So I've shorted these pins. After that, the ground connection here. So you can also connect this here for a better connectivity. Okay. Do not keep any 90-degree connection. So it will create more resistance in the circuit. So this is the wrong connection actually. I will drag the inductor little bit upside because it may short these two pins. Less bend in the tracks, the less resistance we will have. Just connect the output to the capacitor positive. To also pass the ground here. Okay. Let's go to the end point. Saving this file. Now we have some connections remaining like this one, but we don't have any space to connect a top layer line from this point to this point. So we'll go for the bottom layer. For that, you have to click V and get a wire and place it on the top line. Okay, and you will also have to look that beside the wire there should be no other component nearby. And now you can choose the bottom layer, connect, come to this point, or you can just directly connect it to the capacitor because the capacitor has a multi-layer point, so you can connect both top and bottom layer into the multi-layer points, so you don't have to get another wire. And another connection is remaining, that is this feedback connection from R1 and R2. So we also don't have any space in the top layer to go to this point to this point. For that, first we will take top, then we will click in B, it will select the bottom layer and a wire will be automatically added. Then click and go to this point. Here, as we don't have any other multi-layer pad, so we also have to take another wire. So you have to press T again for going into the top layer. So here a wire will be automatically added. So here is the bottom layer line connected to this wire, and the top layer line is also connected to this wire. So I have connected it successfully. Now we also have to do the same, or we can do with the top layer only, as we have the top layer connection here. As we have the space, so we have routed the line in the top layer. Okay, so if there is any error, you have to check it through the DRC, design rule check. So here you can see here are 0 errors. Means our PCB is totally okay. Fine. Now I am going to give the copper area to the PCB for like noise removal. Like if you give a copper ground area, so any noise or frequency generated in this buck converter circuit will be minimized. For that, you have to choose this copper area, or you can just press E in the keyboard, and it will say in which net you want to connect this uh, copper area. So we don't have the ground pin. Let me cancel this one first. And the ground pad net is U1 underscore 4. So we will choose that U1 underscore 4. Fine. Okay. Then we will create a copper area line. You don't need to be very specific point. Just the copper area should cover the whole board, and right click it. Okay. The copper area is given. Means generated. So here are some specification or properties have to adjust. Pad connection, keep it as spoke. Clearance, I prefer to give more clearance like 0.5 mm, let's say. Do it according to your need. And copper to the board clearance should be as it is. Okay, we're not changing any other thing. Now just copy this copper area and select the bottom layer and paste it. Now select here you can see both the copper area is in the top layer. Select one of that and do it bottom layer. Okay, so a copper area will also be created in the bottom layer. So our PCB design is ready. To see the how the PCBs look, you can click the 2D or 3D option. First, let us see the 2D option. This is the top part of the PCB with blue masking and golden pads. Let's change it to the gold and silver. Okay, the basic PCB, and the bottom side. Okay, we only have this, and the spoke means the ground pads are connected like spoke. So this is the spoke thing. Okay, let's close this and open the 3D. So here we have the 3D visualization of the PCB. The 3D model of the inductor is not present here, but you can see the other components like this diode, capacitors, the IC, there is the LED. Okay, so while you are designing the PCB, you will also be able to see how the PCB will look like. Green, make it see. You can also invisible the 3D models to see the bare PCB 3D. Okay, so this is how you can actually design a PCB, and before manufacturing you can visualize the 3D model, and you can also use this 3D model to make any enclosure. For the measurement purpose you will need the 3D model. So that is it for today. I hope you guys like this video, and if so, give a thumbs up and subscribe to my channel if you are new to this channel, and share this video with your friends and technical community. And the most important thing, be creative.